we're going to be talking about cycloalkanes and what their nomenclature is about. Cycloalkanes have the formula CnH2n. If you see, we lost this plus 2 that alkanes have because the bond needs to be able to bond to the other carbon. So that's why we lost it. So cycloalkanes start obviously from cyclopropane because that's when they can go around. And then we have cyclobutane. We have cyclopentyl and cyclohexane and so on and so forth. We can have a lot of carbons. Very important here to remember that in every corner that we have in the cyclostructure, we have a carbon, right? And cycloalkanes can also be substituents. So if we have a larger carbon chain, I can have a cyclopropyl. So the name of this substituent will be cyclopropyl. If we have another one, for example, we could have a cyclobutyl. This would be a cyclobutyl. Very important when we have cyclostructures as substituents to remember that the bond needs to go from carbon to carbon. We cannot have a cyclopropyl that's right in the middle. This will not be a cyclopropyl because this carbon would count extra. So be mindful about that. That is incorrect. Bonds go to corners because carbons are in corners. So let's see what is our first rule for cycloalkanes. The first one is that if we only have one substituent, the name of it would be the name of the substituent. In this case, this is a methyl. This is a cyclo 1, 2, 3, 4, 5. So the name of this would be methyl cyclopentane. There is no need to number the substituent because we only have one. For example, another one would be if we have a substituent, and in this case we'll have a halogen. The name of this would be only the substituent, in this case chloro, and the name of my structure, this is 1, 2, 3. This is cyclopropane. So there is no need to give it a number because it will always be a number 1. The next rule for cycloalkanes is when we have more than one substituent. For example, if we have a cyclohexane, we have this structure here, another one here, and another one here. So we have 3 structures. The first thing that I'm going to identify is the name of my substituents. I have isopropyl here. I have methyl here. And I have ethyl here. So because I have more than one, I have to give them allocation carbon, and I have 6, right? The rule says that you start with alphabetical order. In this case, the number 1 will belong to ethyl. Now I have 2 choices. I either start counting this way or I count this way. I will count in the way where my other substituents have the smallest number possible. So in this case, I know that I need to go counterclockwise because the methyl would have a number 2 and the isopropyl would have a number 4. If I counted to the other side, I would have 1, 2, 3, 4, 5, 6. So my substituents in yellow would be in 1, 4, and 6. And the ones that I have in blue would be 1, 2, and 4. So obviously, counting counterclockwise gives me the smallest number possible. So I'll keep the blue numbering. So now I do follow the rules of alkanes to put them in alphabetical order. So I have 1 ethyl, 4 isopropyl, 2 methyl, cyclohexane. Okay, so now for another structure similar to this, we would have so it's a cyclopentane. It has 5 corners. I need to identify my substituents. So I have 1, 2, 3, 4. This is butyl. And here is a methyl. So I start number 1 because I follow the alphabet is butyl. So then again, I have 2 choices. I can either start numbering 2, 3, 4, or I could number 1, 2, 3. So in red, I would have it in 1 and 3. My 2 substituents in blue, I would have them at 1 and 4. So obviously, the smallest number possible is given with the red numbering. So I'll just erase the blues and keep the red. So my structure would be, I have 1 butyl, 3 methyl, cyclopentane. So that is when we have the cyclo structure as the biggest structure. There are some cases when the cyclo structure is not the biggest structure. For example, on this one. If I have a cyclopropane, so the largest chain is going to be the straight alkane chain because this one has 7 carbons. My cyclo structure has only 3, so that means that the cyclo structure becomes a substituent and the main structure is the alkane. So in this case, I follow the rules that I give. This is a cyclopropyl. I identify my continuous carbon chain. I already did. It has 7 carbons. I start numbering where my substituent has the least number. So I'm in carbon number 3. And then I name it. So I have 3 cyclopropyl, heptane. So remember that when I go from the main structure to a substituent, my ane becomes ill. Okay, another one. If I have this cyclohexane and I have this structure right here, if you see, let's count how many we have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 against my cyclohexane, 4, 5, 6 against my cyclohexane that only has 6. So the main structure is going to be the alkane structure, and the cyclohexane will become a substituent. So in this case, it's in carbon 2. So I have 2 cyclohexyl nonane. So the other one, we would have, let's see this last structure. We would have this structure right here. So in this case, I don't know very well how many my cyclo has, so let's start counting them. Let's start counting them. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 carbons in my cyclo. I have 1, 2, 3, 4, 5. So that means that this 5-carbon chain is going to be a substituent, right? So here I have pentyl. Let me change colors. I have pentyl. Here I have an isopropyl. Here I have a methyl. So these numbers that I wrote before to see how many carbons my cyclo has, they're wrongly placed, because remember that when we have a cyclo structure, we need to give the 1 to the one that comes before in the alphabet. In this case, the one that comes before in the alphabet is the isopropyl, right? Because I comes before anything else. So I need to name it. So if I go counterclockwise, I have 1, 2, 3, 4, 5, and 6. So I have 1, 4, 6 in my substituents. If I go clockwise, I have 1, 2, 3, 4, 5, and 6. I have 1, 3, and 6. So this nomenclature wins, right? The numbering wins. So let me erase the yellow ones. And let's keep the other ones. I already know that I have 6, 7, 8. So let's start naming them. So I have 1 isopropyl. 3 methyl, 6 pentyl, cycloalkane. So those are the rules for naming cycloalkanes. So let's review those rules. So let's review the rules for naming cycloalkanes. The first rule is if you only have one substituent, there is no need to number it. The example of the first rule can be seen here in this one. We only have this substituent right here. So we just put the two names together. So this would be isopropyl, cyclopentane. The next rule says, if you have more than one substituent, assign the carbon 1 to that comes first in the alphabet. Then number the other ones in a way that gives them the smallest number possible. So in this case, my example will be this one right here. We have a methyl and we have an ethyl. So in this case, we will give carbon 1 to the one that has the ethyl. I have two choices. I can either start numbering counterclockwise or clockwise. I see that if I do it in counterclockwise, my methyl would be in carbon number 3, and that will give it the smallest number possible. So now, naming it, I would have 1 ethyl, 3 methyl, cyclohexane. And the last rule would be a cycloalkane can be a substituent. Check who has more carbons. As a substituent, drop the ane and adopt the il. So this rule would be for this last one. Let me change colors. In this case, I have a cyclobutyl. I have 1, 2, 3, 4. And my substituent has 1, 2, 3. So in this case, my cyclobutane has the most carbons. So it's going to be the parent name. So 1, 2, 3, it's going to be propyl cyclobutane. In the other case, I still have 1, 2, 3, 4, but the carbon chain is 1, 2, 3, 4, 5. So the parent name is going to be pentane. So the cyclobutane, it's not going to be butane, it's going to be butyl. So let me name it. It's in number 1. So I have 1 cyclobutyl pentane. So those would be the rules for naming cycloalkanes.